Okay, so hello class, welcome back. So in this recording, we're gonna take a look at chapter 11, or more specifically, we're gonna take a look at section 11.1. So what's the idea for chapters 11 or section 11.1 then? So the idea of chapter 11, we're gonna talk about, so it's gonna be about inferential statistics regarding two sample or two population parameter using two sample. So that's going to be the idea for chapter 11, inferential statistics regarding two population parameter using two sample. So because we're going to use in two samples, so before we can move on, let's give you some definition. So when you compare two sample, then when you're using the two sample to compare two population parameter, the sample that we might use it might be independent or dependent. So what does it mean both for the sample to be independent, or what does it mean for the sample to be dependent? Okay. So a sampling method is independent when the individual selected for one sample do not dictate which individuals are to be chosen in the second sample. So which means that after you selected an individual in the first sample, you have no information who's gonna be selected in the second sample. They're not related. So that's gonna be independent. A sampling method is dependent when the individuals selected to be in one sample are used to determine the individuals in the second sample. So which means that after you selected the first person to be included in the first sample, you're going to know exactly which individual will be selected in the second sample. They're going to be related. So dependent samples are often referred as matched pair samples. Is it possible for an individual to be matched pairs against himself or herself? Yeah. So you might see this scenario for dependent sample. So we're gonna an individual can be matched pairs against him or herself. Look like in the clinical trial research, right? You're gonna use the same person, but we're gonna do the measurement before they take the medication, and we do the same measurement after they take the medication. So it could be possible for you to use independent samples, and then the individual will be matched pairs against himself or herself. So that's going to be the definition for independent and dependent sample. So independent sample, which means that the two samples that we selected, they are not related. For dependent sample, which means that the two samples that we selected, they are somehow related. Okay. So based on the definition of independent and dependent sample, so now let's take a look at the two examples. Let's give it a try. Let's see if you can determine if they are independent or dependent. So for the question A, so let's take a look at this scenario and see if they are independent or dependent. So a researcher wants to compare the price of some particular item as Walmart and Target. So in order to do so, the researcher chooses a Walmart, and then she chooses the Target that's either closest to that Walmart, and compare the prices at those two different stores. She does this for 10 different sets of stores. So you're gonna compare the price of some item between Walmart and Target, right? So when you select an item when you selected a Walmart, then do you know what Target we're gonna select that? Okay. So that's gonna be the clue, right? So if you know exactly what target that we're gonna select it, then those two samples gonna be dependent. Okay. So the researcher choose a Walmart, and then she choose the target that's either the closest. Yeah. So she's gonna choose the target that's either the closest to the Walmart. So that's gonna be the indication that those two samples gonna be dependent. Yeah. So the closest target close to the Walmart. Yeah, so the closest target to the Walmart, that's we're gonna select it automatically. So those two samples gonna be dependent. Yeah. Okay, so that's it gonna be dependent sample. How about the next one? A researcher wants to know if the new penny that are made with more copper have a mean weight that's heavier than the older penny that were made with more zinc. The researcher gathered 20 new pennies and then 20 old pennies and weighed them to compare. So we're going to compare the mean weight of the 20 new pennies and then another 20 old pennies, right? And we want to see if the new one's going to be heavier than the old one. So after you selected a new penny, do you know exactly which own penny we're gonna select it? No, right? So we have no clue which own penny we're gonna select it after we select a new penny. Okay. So because it's not gonna give you any indication which own penny will be selected. So that's why we're gonna say that the two samples that we have right here, they're gonna be independent. Yeah. So they're not dependent. Yeah. So they're gonna be independent. Yeah. So this is gonna be independent. Okay, so there's nothing to relate those two. Yeah, so for the first one, the closest target to the watermark will be selected. So there are some indication that you're gonna know what target will be selected. For the second one, right here, after you select a new penny, you have no idea what own penny will be selected. So they're gonna be independent. So after we got the ideas of independent and dependent, now we are ready to talk about these hypotheses. Okay. Or we're ready to talk about inferential statistic. Yeah. So when we using the term inferential statistic, which means that you're gonna do two things. You can do the confidence interval based on the ideas of chapter 9, and then you can do the hypothesis based on the chapter 10. Okay. So let's take a look at section 11.1. So we're gonna talk about inference about two population proportion from independent sample. So we're going to do inferential statistic about two population proportion. This is going to be two population proportion. And then we're using from independent sample, from independent samples. So inferential statistic, which means that we're going to do the hypothesis and we're going to do the confidence interval. So we're going to take a look at the first inferential statistic first, which is the hypothesis test. Yeah. So we now compare the two proportion, testing if they are the same or not. Okay. So testing the claim regarding two population proportion. Now, because we're going to compare two population proportions, so you need to use in the subscript to distinguish between the first and the second, right? Excuse me. So in the test of two population proportion, we have two values for each of the variable, one for each of the two sample. So we're gonna get two population proportion. So we're gonna use the subscript P1 and P2. That's gonna be the two population proportion P1 and P2. We're gonna get two sample size N1 and N2. And the two number with some certain characteristic X1 and X2. Excuse me. So when comparing two population proportion, the known hypothesis is the statements of no difference. Yeah. So no difference, which means that the two population proportion will be equal. So that's why the way that we're gonna state the known hypothesis is P1 is equal P2, or equivalently, we can say that P1 minus P2 is equal 0. So when the two numbers have no difference, right? So when you subtract them, the difference will be 0. So there's no difference between those two population proportion. So you can either stay this way or this option, but most of the time we're gonna go with the option number 1. So for the known hypothesis, we're gonna say that's P1 is equal P2. So since we do not know what the P1s and P2 are, we can assume that both the P1s and P2s are equal to some variable P, where P is a common proportion. So we're going to introduce another variables, a common proportion. So we need to estimate the common proportion P because it is unknown, right? So how we're going to estimate a common proportion? So the best estimate for the common proportion P is called the pool estimates of P. And then denoted by P hat. So how we're going to calculate P hat? Okay. So P has equal X1 plus X2 divided by N1 plus N2. So this is the pool estimate of the population proportion. So this is the pool estimates of the population proportion P. So that's going to be P has equal X1 plus X2 divided by N1 plus N2. Okay. So we're going to do this calculation. This is the pool of the two samples together. And that's going to be the pool estimate for the common population proportion. Okay. So we're going to talk about the hypothesis. So we're going to use the same ideas with the hypothesis that we learned from chapter 10. So step number 0, you need to double check the condition, right? So let's see what's going to be the requirements or the condition for the hypothesis test. Yeah. So there are 3 requirements that we have to double check before we move on for the hypothesis then. So the first requirement, the samples are independent, obtained using simple random sampling. So the 2 samples, they're going to be independent, and we make sure that it's a simple random sample. The 2 samples that we are selected at randoms, and they're going to be independent. That's going to be the first requirement. The second requirement is N1 times P1 has 1 minus P1 has more than or equal to 10. N2 times P2 has 1 minus P2 has more than or equal to 10. So you want to use in this condition to make sure that we have a normal distribution. Now, the third requirement that each sample size is no more than 5% of the population. So N1 less than 5% of 0.05 times uppercase N1, and N2 is less than or equal 0.05 times uppercase N2. So each sample size is no more than 5% of the entire population. So that's going to be the requirement for the hypothesis test, to compare 2 population proportion and using 2 independent samples. Yeah. Okay, so that's going to be the 3 requirements. After we double check the requirement, then we're going to move on and then move on to step number 1. So step number 1, we're going to determine the known and the alternative hypothesis, right? The known hypothesis, there is no difference between the 2 population proportions. So the way that we say the known hypothesis is P1 is equal P2. The 2 population proportion gonna be equal. For the alternative hypothesis, you have to take a look at the claims and then decide what's gonna be the inequality that we use it for the alternative hypothesis. So you might say P1 not equal P2 for the two-tailed test, or you can say P1 less than P2 for left-tailed test, and then P1 more than P2 for right-tailed test. So that's how we say the the alternative hypothesis and how we determine the tails of the hypothesis. So that's going to be step number 1, right? So after we're done with step number 1, now we're going to move on to step number 2, which is selecting alpha, right? Select the level of significant alpha based on the seriousness of making type number 1 error. Yeah, so that's going to be step number 2. The most easy step in your hypothesis test with a selecting significant level alpha. The common values of alpha will be 5% if the question don't give you the values of alpha there. Now, step number 3, we're going to calculate the test statistics. So we're going to use this provided formula to calculate the test statistic. Yeah, so this is the formula that we use it for the calculation of the test statistic. So in this calculation, we have P1 has the first sample proportion, P2 has the second sample proportion, P has the pool estimation of the population proportion, and P has equal x1 plus x2 divided by n1 plus n2. And then n1 is going to be the first sample size, and n2 is going to be the second sample size. So that's how we calculate the test statistic for step number 3. So after we're done with step number 3, now we're going to move on, calculate the p-value, right? So step number 4, you're going to draw the standard normal curve and obtain the p-value using the 2 proportion z-test. So we're going to use this shortcut from the calculator to help you with the calculation of the p-values. So p-values equal the answer from this calculation to proportion z-test. So the calculation of p-value depends on the numbers of tails that we have in the hypothesis. Yeah. So we're going to use this shortcut to proportion z-test to get the answer for p-values. So this is the step-by-step how we using the shortcut to proportion z-test to get the answer for p-values. So we're going to go start, and then we go to the test option, and we go down to the option to proportion z-test. After that, you input x1, x2, n1, n2s, and then select the direction of the alternative hypothesis, and then go down to the calculate. So that's going to be step number 4, using the shortcut to get the answer for p-values. Yeah. Now, step number 5, we're going to compare p-values and alpha to get the conclusion, right? So if p-values is less than alpha, we're going to reject the known hypothesis. If p-values is more than alpha, we fail to reject the known hypothesis. The same rule of decision as we have earlier. If p-value less, we reject the known hypothesis. If p-values is more, we fail to reject the known hypothesis. And then after you got the conclusion of either reject or fail to reject, then you're going to move on to step number 6, right? Answer the question of interest based on the context of the application. So you're going to state it as there is sufficient or there is insufficient evidence to support the alternative hypothesis. Yeah. So in terms of the procedure, we're going to use the same procedure for the hypothesis, similar idea with what we have learned from chapter 10, right? Now, the only thing different for this chapter 11 is we compare two population, right? So we're going to compare two population parameters using two samples. And once again, you have to determine if the two samples going to be independent or dependent, okay? So you might pause the recording for a few minutes and review the procedure for the hypothesis test. And then after that, whenever you're ready, just moving on. And we're going to take a look at the first practice question then. Okay. So we're going to take a look at the first practice question. We're going to show the step-by-step, and we're going to use a shortcut to get the answer for step number 4, which is the p-values. Okay. So an economist believes that the percentage of urban households with internet access is greater than the percentage of rural households with internet access. So he's obtained a random samples of 800 urban households and find out that 338 of them have internet access. He also obtained a second random sample of 750 rural households and find out that 292 of them have internet access. So test the economist claim at alpha is equal 5% level of significance. Assume that the condition has been verified. That's good. So assuming that the condition has been checked, everything good. So we just perform the hypothesis. So test the economic claim. So we're going to test the claim. So what is the claim that we have then? So an economist believes that the percentage of urban households with internet access is greater than the percentage of rural households with internet access. So we're going to compare the percentage or proportion, right? And then in this case, we compare two. So this is going to be the urban household. That's the first one. And we're going to compare with the rural household. And then the characteristic is they have internet access. So having internet access is a set. And then doesn't have internet access is failure. Okay, so we're going to compare two population proportion. So you need to label which one is the first one and which one is the second, right? So you might say that the urban household going to be the first population, and then the rural household will be the second population. Yeah. Okay, so the urban household going to be the first one. So I'm going to label this as the first, and then I'm going to label the rural household as the second. Okay. Now, for the first sample, he got 800 urban households, and he found out that 338 of them have internet access. Okay. And he also obtained another 750 rural households, and he found out that 292 of them have internet access. Okay. So let me summarize the question so far, everyone. So we have N1 equal 800, and we have X1 equal 338. We have N2 equal 750, and we have F2, which is equal to 92. Okay. So now based on these values, I can calculate these P1 hat. Okay. I need to calculate the first sample proportion, P1 hat. Okay. So going to be P1 hat equal X1 over N1. Okay, so which is equal 338 divided by 800. Okay, so let's see what's the answer of this then using your calculator. So we have 338 divided by 800. So 338 divided by 800. So this is going to be 0.4225. Okay, so 0.4225. Similar ideas, I'm going to calculate P2 hat. So it's equal x2 divided by n2, which is 292 divided by 750. And I'm going to round the answer with 4 decimal place also. 292 divided by 750. This is going to be 3893. Yeah, so 0.3893. And then I'm going to do the other calculation, which is the p hat, right? The pool, yeah, so the pool common proportion. So p hat. So p hat equal x1 plus x2 divided by n1 plus n2. Okay. So we have x1 is 338 plus x2 292 divided by n1 was 800 plus n2 750. Okay. So parenthesis 338 plus 292, close the parenthesis, divided by parenthesis 800 plus 750. So 4665, 4065, 4065. Okay. 0.4065. Okay. So that's going to be the sum of the calculation that we might need to do in advance to help you get ready for this hypothesis test then. Okay. So once again, we're going to compare two population proportion, the urbans and the rural household, and then the characteristic we focus on if they have internet access then. So the first population will be the urbans and the second one is going to be the rurals. Okay, so we're going to compare the two population proportion. Now we're going to go to step number 1. Let's determine the known and the alternative hypothesis. Yeah. So for the known hypothesis, I'm going to say P1 is equal P2. So there's no difference between those two population proportion. For the alternative hypothesis, what should be the inequality we're going to use then? So the urban household with internet access is greater than the rural household with internet access. So look like that the urbans will be number 1 and then the rural is going to be number 2. So urbans is greater than. So going to be look like P1 more than P2. Okay. So that's going to be the hypothesis, right? So now based on the alternative hypothesis, can you guys determine the tails of the test then? It is going to be two tail, left tails or right tail test. So for this hypothesis, we do equal versus greater than, right? So this is going to be right tail test. So this test is going to be right tail test. Okay. So that's going to be step number 1, determine the known and the alternative hypothesis. Now, step number 2, the most easy one, right? We're going to select the significant level alphas, and then alpha is equal 5%. Okay. So we are given that alpha is equal 5%. So this is significant level alpha equal 5%. So now step number 2 is done. Let's move on to step number 3, right? So step number 3, we're going to use the formula to calculate the test statistics then. So what's going to be the formula to calculate the test statistics? Oh, wow, this is a lengthy formula, right? Okay. Okay, so now let's see what we have so far, right? So in this calculation, we need to know P1. Do we know P1? Yes. Yeah, so we know P1 has already 4225. So I'm going to substitute that. So P1 has equal 0.4225 minus P2 hat was a 3893. 0.3893 divided by the square root of and then in this square root, I got P hat. What's a P hat then? So P hat is equal 4065, 0.4065, 1 minus 0.4065 times it by 1 over N1. So what's the N1? N1 is equal 800, N2 is equal 750. So 1 divided by 800 plus 1 divided by 750. And then in order to make sure that you got this calculation right, I will recommend that you put the parenthesis around the subtraction on the numerator. Okay. Okay, so this is going to be the formula that we use it to get the answer for the test statistic, right? Now let's give it a try with the calculator. Let's see if you can get the correct answer for this calculation then. So we're going to get parenthesis 0.4225 minus 0.3893, close the parenthesis, divided by second square root of 0.4065 parenthesis 1 minus 0.4065, close the parenthesis, open another one, 1 divided by 800 plus 1 divided by 750. Okay, so then hit the enter keys, everyone. We have the answer going to be 1.3299. 1.3299. Okay, 1.3299. Okay, so that's going to be the answer for step number 3, right? So we just got the answer for step number 3. So, okay, so now let's move on to step number 4 then. Okay. So for step number 4, we're going to use the shortcut to get the answer for the p-value, right? So what's the shortcut then? So I'm going to say using 2 proportion z-test to have the answer for p-values equal. Okay, so we're going to use the shortcut to proportion z-test to help you with the calculation of p-values then. So to proportion z-test. Yeah, so this is the shortcut. We're going to use it to proportion z-test. So let's take a look up this shortcut to proportion z-test in your calculator then. So we have the summary in the previous page already. So you might take a look at this so we can know the step-by-step how to access that to proportion z-test. Yeah. So we're going to go stats and we're going to go to the test option. And we're going to looking for the test option. So to proportion z-test option number 6. Yeah. So to proportion z-test. So we're going to go down to option number 6 to proportion z-test. So after you select the to proportion z-test, the calculator will asking what's the x1. So x1 is equal to 338. Okay. Enter. N1 is equal 800. And then x2 is equal to 92. And then N2 is equal 750. And then for the alternative hypothesis, we're going to get more than. Yeah, so P1 is more than P2. Make sure that you go to this option and hit the enter key to select that to highlight that option. And then after that, we're going to go down to the calculation. Okay. So we can double check the answer for the test statistics, right? So this is going to be, because we're using the rounded answer, so the answers is very close, but it's not, yeah, right? So this output is going to be the test statistics. So it's going to be 1.32986, right? We have 99. So it's got a little bit off, right? So, but that should be okay, yeah. So because we're using just 4 decimal place, the calculator using more decimal place, that's why the answer is going to be more accurate. Yeah, so this is the answer for the test statistic, 1.329. Yeah, so, and then how about the p-value? Then the p-value is equal 0.0919, right? 0.919, and the next one is a 9, so I have to round it to 20. Yeah, so p-value is equal 0.0920. Okay, so 0.0920. So we just using the shortcut with all of the values from the question to get the answer for p-values. Okay. Now, after we got the answer for p-value, you are ready for step number 5, right? Now we're going to compare p-values and alpha then. So p-values equal 0.0920. And then alpha from step number 2, we have alpha is equal 5%. So now we're going to copy alpha. And then we're going to compare them. So p-values and alpha, p-values is less or more. So p-values equal 0.09 and then alpha is equal 0.05. So look like p-values is more than alpha, right? So p-values is greater than alpha. So what's it going to be your decision then? Do we reject or fail to reject the known hypothesis? So if p-values is less than alpha, we reject the known hypothesis. If p-values is more than alpha, we fail to reject the known hypothesis. Yeah. So because p-values is more than alpha, we fail to reject the known hypothesis. So when you fail to reject the known hypothesis, would mean that the known hypothesis is still true. So if the known hypothesis is true, which means that the alternative hypothesis is not true anymore. And then your final conclusion is based on the alternative hypothesis. That's why we're going to say there is insufficient evidence. Yeah, so there is insufficient to conclude that that's what I'm going to copy the claim. Yeah, that the percentage of urban households with internet access is greater than the percentage of rural households with internet access. Okay. So we don't have sufficient evidence to say that the urban household will have higher proportion of internet access than the rural household. Yeah. Okay. And then if you want to be more specifically, you might mention the alphas also, right? So at 0.05 significant levels of significance. Okay, so this is gonna be the hypothesis test to compare two population proportion. Okay, so in this case, we compare the urban and the rural household. Yeah, so this is the first example. You might pause the recording for a few seconds, right? And take a look at the work that we completed together. And then whenever you're ready, just moving on to the next example then. Okay. So this is the first question, the first hypothesis that we work together to compare two population proportion using two independent samples. Okay. Now let's give it a try again, right? I think we have the second practice question. Now let's give it a try. Yeah. Let's give it a try again. Okay, so now we're gonna take a look at the second example. Okay. So researchers compare the proportion. Okay, so they compare proportion again. So researchers compared the proportion of children who come to school without eating breakfast in two randomly selected low-income elementary schools. So 19 out of 80 students from school number 1. So 19 of 80 students from school number 1. And then 26 of 150 students from school number 2 has not had breakfast before coming to school. So they're going to compare two different schools, right? Do these data give you a convincing evidence of a difference in proportion, in population proportion? Carry out a significant test. Carry out a significant test at alpha is equal 5% significant level to support your answer. Assume the condition has been verified. Okay, that's good. So which means that step number 0 has been checked, so you don't have to worry about step number 0. So let's take a look at the claim again. So this researcher said that the proportion of children who come to school without having breakfast in two different ones, and then there is a difference between those two different schools. Yeah, so the school number 1 and school number 2, we're gonna compare the proportion of students that doesn't have breakfast before they come to school. So we're gonna compare two proportion, and then those two schools, they're gonna be independent, right? So after you select a student from school number 1, you don't know which student we're gonna select it from school number 2. So they're gonna be independent. So to summarize the question again, right? So let's see what we have then. So we're gonna get n1 equal 80. And then x1 equal 19. We have n2 equal 150. And then x2 equal 26. Okay. Now, based on these values, based on this data, we're going to calculate P1 and P2, right? So let's do similar idea with what we have earlier. Yeah. And then the pool also. Yeah. Okay, so we have x1 over n1. So x1 is equal 19 divided by n1 is equal 80. Let's see what's the answer of this then. So 19 divided by 80. So going to be 2375. 19 divided by 80, 2375. 0.2375. And now for the second sample proportion, we're gonna get 26 out of 150. Okay, so 26 out of 150, so 26 divided by 150. So 1733, yeah. Okay, 0.1733. And then the pool population proportion is gonna be 19 plus 26 divided by 80 plus 150. Okay, let's see what's the answer of this calculation. Then make sure that you have the parenthesis. So we're gonna get 19 plus 26 divided by 80 plus 150. Okay, so gonna be 1957. 1957. Okay, 0.1957. Okay. So on up these value that we just calculate in advance, so that's gonna help you to perform the hypothesis a little bit easier, faster. Okay. So assuming that the condition has been verified, so step number 1 is, or step number 0 is already done, right? Now step number 1. So we're gonna determine the known and the alternative hypothesis. So once again, score number 1 is gonna be the first population or the first samples, and score number 2 is gonna be the second population. So for the known hypothesis, it's gonna be P1 is equal P2. Okay. So the first population proportion equal the second population proportion. How about the alternative hypothesis? Based on the claim for this question, what should be the inequality that we use it for the alternative hypothesis? Yeah. So for this hypothesis, we want to test if there is a difference, right? So there is a difference. So we're gonna use the not equal to determine if there is a difference between those two population proportion. So P1 not equal P2. So for this hypothesis test, we have equal versus not equal, right? So can you guys determine the numbers of tails for the test? Two tails, left tails, or right tails? So because this is equal versus not equal, so this is gonna be two tail test, right? So this is gonna be two tail test, yeah. So this test is gonna be two tail test, yeah. Okay. So that's going to be step number 1, we just determine the known and the alternative hypothesis. Now step number 2, we select an alpha, right? So alpha is equal 5%, right? So I'm just copy that alpha from the question. So alpha is equal 5%. Now step number 3, we're going to calculate a test statistic, right? So we're going to calculate the test statistic, then step number 3. Okay. Okay, so let me copy the formulas and then we're gonna plug in the values and use a calculator to see what's the answer for the test statistic then. Okay. P1 has, so P1 has equal 2375. Okay, so that's gonna be 0.2375 minus P2 hat, which is 1733. Divided by P, the square root. Okay, don't forget the square root, right? And then P hat 1957, 0.1957, 1 minus 0.1957, times it by 1 divided by N1. N1 is equal 80, plus 1 divided by N2, 150. So this is going to be the calculation for the test statistic by using the provided formulas, right? Okay. So now let's using the calculator to find out what's the answer for the test statistic then. So parentheses 0.2375 minus 0.1733 divided by second square root of 0.1957 parenthesis 1 minus 0.1957 close parenthesis, open another one, 1 divided by 80 plus 1 divided by 150. Okay, So the answer is going to be 1.1688. Okay. 1.1688. Okay. So that's going to be the answer for the test statistic there. Okay, so using the provided formulas on this section, 11.1, we have the answer for the test statistic, right? Okay. Now, step number 3, you need to draw the curve and calculate the area, right, to get the answer for p-value. But luckily, we have the shortcut. So I'm going to say using to proportion z-test to have the answer for p-values equal. Okay. So the shortcut that we're going to use is going to be the 2 proportion z-test. Okay, so 2 proportion z-test is the shortcut that we're going to use. Okay. With all of those data, everyone, x1, n1, x2, n2. So let's try it one more time with the shortcut then. So we're going to go to stat and then test, and then we're going to go down to option number 6, right? So 2 proportion z-test. Now x1 is equal 19. Enter. N1 is equal 80. Enter. Now x2 is equal 26. Enter. And then N2 is equal 150. Enter. Now the alternative hypothesis is not equal. So make sure that you highlight the not equal and hit the enter key to make your selection of that not equal, right? So there's going to be 2 tail tests. And then we're going to go down to the calculate. Okay. So we have the answer for the test statistic, right? So this is going to be 1.1683. We have 88. That's close enough, right? And then the p-value is equal 0.2427. 0.2427. The second output is the answer for p-value right here. 0.2427. Okay. So 0.2427. Okay. Okay, so we just got the answer for p-value. Now, after we got the answer for p-values, we're going to move on to step number 5. Compare p-values and alpha to get the conclusion, right? The decision, right? Of reject or fail to reject. So p-values equal 2427. And then alpha from step number 2, we have alpha is equal 0.05. So based on this comparison, we know that p-values is more than alpha, right? So p-values is greater than alpha. Yeah. Okay, so p-values is greater than alpha, then what's your decision then? Do we reject or fail to reject the known hypothesis? Okay. So if p-values is less than alpha, we reject the known hypothesis. P-values is more than alpha, we fail to reject the known hypothesis. Yeah. Okay. So if we fail to reject the known hypothesis, would mean that the known hypothesis is true, right? And when the known hypothesis is true, would mean that the alternative hypothesis is not true, right? So that's why we have insufficient evidence to support the alternative hypothesis. Yeah. So there is insufficient evidence to conclude that that's what? That the proportion, yeah. The proportion of children who come to school without eating breakfast. Okay, so I'm going to copy this claim and I'm going to state the claims answer. Yeah. So that's the proportion of children who come to school without eating breakfast in 2 different randomly selected elementary schools are different. Yeah. At 0.05 level of significance. Okay, so this is gonna be your final conclusions. Okay, for this hypothesis. Okay. So once again, for this hypothesis, we're gonna compare 2 population proportion using 2 independent samples. So in terms of the hypothesis test, we're gonna do the similar idea. The step-by-step, the procedure will be similar with the hypothesis test that we learned from chapter 10. The only thing different is in this chapter 11, we compare 2 population parameters. So once again, in this recording, we just compare two population proportion using two independent samples. Yeah, so using two independent samples. Yeah. So this is gonna be the hypothesis test, right? Okay, so I think I'm gonna stop the recording at this point, everyone. I'm gonna do the hypothesis in the next recording then, okay? Okay, so this is about the hypothesis test to compare two population proportion using two independent sample. I will see you next time for the next recording, yeah.